Hi, good evening and welcome to today's class. Thank you very much for your patience and spending time to be with us again. As promised, I think last week I sent an email out regarding load shedding. So that has since been taken care of, so we shouldn't be expecting those problems going forward. So again, I'd like to apologize for the inconvenience that has been caused in the past 2 weeks or so. All right. So seeing that we're going to be moving forward. Last time we talked, right? We were discussing, or what we've done so far is we've done a revision of regular expressions and finite automata, right? We said in the exam it constitutes about 7 marks, right? And then the conversion from regular language to context-free language, right? So we did examples of that. Now we all want to look at a section of chapter 13 called Chomsky normal form, right? So we have done quite some examples of context-free grammar, right? So what we want to do is now to prove that all CFGs, right, can be written in the form of a non-terminal goes to exactly 2 non-terminals, right? Or a non-terminal goes to exactly 1 terminal. So what we want to prove is that we can write all CFGs in this format, right? And this format has got an advantage, right? If you look at computers, we know that computers are made up of logic gates, right? And the logic gates, if you're looking at an AND gate or a NAND gate, you've got 2 inputs, right? 2 inputs, A, B input here, leading to 1 output, right? So this is 2 to the power of 0, and then this is 2 to the power of 1, right? So you are writing this in the form of in a binary language, sort of, right? So this is a better way of giving out the instructions and breaking down the CFG, especially when you look at assembly languages, right? Now, if we have this, okay, how do we get to this? So this format is called the Chomsky normal form. Chomsky normal form. All right, now looking at Chomsky normal form, we can do the following for us to get to Chomsky normal form. There are 4 steps that we need to follow for us to get to Chomsky normal form. Number 1, we need to take care of what are called, we remove, or if you read in the book, they say kill null productions. Kill null productions. Then number 2, we need to remove or kill unit productions. And then the third part, we need to normalize, right? Then number 4, we'll put it in Chomsky normal form. So these 2 will be treated as one step. Right? We'll see how we do that later on, right? So we just convert to Chomsky normal form here. All right, for us to do that, we're going to use an example, all right? So we're given a grammar and we're supposed to convert it in Chomsky normal form, right? So what you notice here is that you have got all these, right? There are words that can be formed. I can see words starting with an A go to X and they end with an A. So words such as A are acceptable, B are acceptable, and so forth, okay? So these words are acceptable in that regard. See, if you start with an A, you end with an A. If you start with a B, if you start with a B, then you end with a B, right? So there are some words that are accepted in this language. Right, now let us move to convert it to Chomsky normal form. Right, we said the first step is to remove null productions. We first need to describe what are null productions. Null productions are those rules where we've got a non-terminal going to a null. Right, in this case, if we list our null productions, we've got our null productions. We have Y goes to null and Z goes to null. Right, so we don't only stop there, we have others that are called nullables. Right, so we say a non-terminal is nullable if it eventually goes to a null. So we are saying non-terminal eventually goes to null. What does it mean? Say we've got S goes to, over here we've got S goes to YZ, right? We know that S goes to null, and so we have got S goes to YZ, and this goes to null. So eventually we are saying S eventually goes to null. Then we would say that S goes to null is a null production. So we would then come and put S goes to null. Right, but we do not have this production, and we are not using it in the meantime. But I just wanted to make mention of what are called nullables. Right, now we've got the null productions. Let us look at what do we do with them. Right, so if we've got these null productions, we want to kill or remove or eliminate these null productions. How do we eliminate them? So we eliminate them individually in each of these productions, right? And by doing so, we've got new productions being formed. So we've got new productions formed. New productions formed. Right, so which productions are formed? Which new productions are formed? So we have got S going to YB, right? So if this Y goes to null, then we know that S goes to B becomes a new production that is formed. Right. Let's go to, so for S, this is the only one that we can deal with. Now for X, we've got X going to Z. So if this Z goes to null, we've got X, Y, Z. Or if this Y goes to null, we've got Z, X, Z. Or if this Z goes to null, we've got Z, X, Y. All right. So we have terminated individually the nulls, this Z, this Y, and that Z. But additionally, it is possible that Z and Y can both be null, in which case we have got, if Z and Y are both null, we're left with X, Z. Or it could be that Y and Z are both null, in which case we've got Z, X. Or it could be that these two Z's are null, in which case we're going to have X, Y. Right. Now, it could also be that all three of them are null, in which case we only have X. Right? We only have X in this case. Now, if we look at it, these are all the possible substitutions that we can have for the Y and Z going to null in X. If you go to Y goes to B, it goes to BY, it goes to null, right? So this Y can go to null, leaving us with B. But we already have a production of Y going to B, so it is not going to be a new production. We do not have to list it because the production is already there. Z goes to A, there are no new productions there formed. So these are the new productions that are formed as a result of eliminating the null productions. Now, the killing of null productions lead to a new CFG being formed. New CFG formed Right. The new CFG formed will consist of the old CFG plus the new productions less. So we're going to have old CFG plus new productions less null productions. Essentially, what we have done is we have said we have substituted every possible substitution for a null production. We've exhausted it here, and we're going to replace those substitutions for these two. We're saying these two could have given us all these 1, 2, 3, 4, 5, 6, 7, 8 productions. Right. So the new CFG formed, we're going to have S going to AX or Y, B or B. Then we're going to have X going to Z, X, Y, Z, X, Y, Z, Z, X, Z, Z, X, Y, X, Z, Z, X, X, Y, X. And then we've got this A. Then Y will go to B and B, Y, and Z will go to A. So this is the new CFG that is formed without the unit or the null productions. All right. Now, let us move on to step number 2. Now, step number 2 says we need to eliminate unit productions. Number 2, we need to kill unit productions. What are unit productions? So unit productions goes as follows, right? We've got productions of the form non-terminal goes to exactly non-terminal. We call this a unit production. Remember, unit means 1. So in this unit production, we have got redundancy in the sense that you're saying Z goes to X, right? Whereas we could have, and then X goes to A, X, say B, BY, or whatever. Now, for example, right? We're saying Z goes to X and X goes to that. So this is just a passing through point. We could have Z going to AX, BY now directly, right? So to kill those unit productions, we need to list the unit productions. The unit productions that we have, we've got only one in this case, which is X goes to X, right? And if we see here, if you check, we would like to find, so let's be consistent, X goes to X. And the new CFG formed, here, so new CFG formed, new productions formed. The new productions formed here, we won't have any because we are still going to take this with the exception of X itself, right? So here we've got no new productions formed, right? And then the new CFG formed, new CFG, we are simply going to have the old CFG less the unit production. So we're going to have S goes to AX, Y, B, B, X goes to Z, X, Y, Z, X, Y, Z, X, Y, Z, Z, X, Z, Z, X, Y, X, Z, Z, X, X, Y. We don't do the X, we go to A, then Y goes to B, by z goes to a. Right. Next, we now need to convert to Chomsky normal form. Chomsky normal form. Chomsky normal form. All right, so we're going to do this in two steps. One, we're going to put all the productions in the form of non-terminal going to non-terminals only, or a non-terminal going to exactly one terminal. If a production is not of this form, then we're going to convert it to one of that form. Right. So how do we do that? If we've got, say, for example, S goes to AX, right? If you want to put it to in this format, right? We know it cannot be this format because it already has. We cannot put it to one terminal, but it can. Let's try and put it in this format. So what we do is we generate a non-terminal representing A, and then we define that production for non-terminal A. Right, so we now have two productions. One is in this format, the other is in that format. Right, so if we see here, you are going to have S goes to AX or YB, B. X goes to Z, X, Y, Z, X, Y, Z, Z, X, Z, Z, X, Y, X, Z, Z, X, X, Y, or A. Right. Then Y goes to B or BY, and Z goes to A. Okay. And then we now need to give the new production for A and for B. So A goes to A and B goes to B. So this is the new production form formed when we convert it to this format. Right? We normalize it. Then we're left with one step, putting it into actual Chomsky normal form. So if you put it into the Chomsky normal form, we now need to have non-terminal going to exactly two non-terminals, and or the non-terminal goes to exactly one terminal. So this is already sorted. We now need to sort this out. Right, now for S, we are okay. Okay, how do we do that? Let me demonstrate how we do it. If, for example, we've got S, X goes to Z, X, Y, Z. There are two ways to do it. The first one, you can say X goes to Z, right? Then you introduce a new non-terminal, let's call it R1. The R1 would be going to X, Y, Z, right? But we cannot write X, Y, Z, so it will be X, and then this becomes R2, and R2 will be Y, Z. So we have got these three representing this one. So if we back substitute R2 into R1, R2 into R1, we've got X, Y, Z. R1 into X, we've got Z, X, Y, Z. Hope that makes sense. Then the other method would be to say X goes to, right, you group them together, R1, R2, then R1 would go to ZX, and R2 would go to YZ. Right. So these are the two options that you have to use when grouping them. So now we know that this part S goes to AX, it's fine. This 2, Y, B, it's 2, B is 1, that's fine. Then X goes to ZX, BY. If we use the first option, we're going to have R1, R2. Then let's list R1 and R2 before we forget where they are. It's ZX and Y, Z. Right here we've got X, Y, Z, but we already have Y, Z, right? So we can have X, R2. We've got ZX, Z, we already have ZX, which is R1, Z. ZXY, it's R1, Y. XZ, it's already good. ZX is already good. XY is already good. A is good. Right. Then we now move on to Y. Y goes to B or BY. Then Z goes to A goes to A, B goes to B. So that becomes our CFG in Chomsky normal form. All right. Any questions? Questions? Right. So this redundancy, right? When we talk of functional, we're not supposed to have this, but for the sake of this simplification, right, rather have Z goes to A goes to A, right? Generate your own new non-terminals so as to avoid any potential mistakes, right? What do I mean potential mistakes? If you take Y goes to B and you promote S goes to Y, what you're opening up is room for this BY being used as well, which is not correct. All right. Cool. So let's do the assignment question 4. Question 4. So this is assignment 1. So convert the grammar below to Chomsky normal form, and that's for 10 marks. So the first thing we need to do is to kill null productions. All right, so we give the null productions, and then we list them down. We've got Z goes to, no, Z is fine. We've got X goes to null. We've got Y goes to null, and Z goes to null. Right, so if we do this, right, we'll see that S goes to X, Y, Z, and this goes to null. So eventually we're saying this goes to null. So S also goes to null. It's a nullable. So you say S is nullable. Right. So we're killing the null productions. The new productions formed. New productions formed. Right, we've got number 1, S goes to AX, so we've got S goes to A. S goes to YB, we've got S goes to B. S goes to X, if X goes to now, we remain with YZ. If Y goes to now, we remain with XZ. If Z goes to now, we remain with XY. If XY goes to now, we remain with Z. If XZ goes to now, we remain with Y. If YZ goes to now, we remain with X. Right. We've already listed this S going to now, so we're not going to, if we eliminate all 3, it goes to now, so we already know that X goes to S goes to null. Then X goes to XY. So if we take out the X, we remain with Y. If we take out the Y, we remain with X. Y goes to B, BY. If we take out the Y, we remain with B, which is already there, so this is not a new production. And then Z goes to A, goes to null. So these are the new productions formed. Now to give the new CFG formed, we've got S goes to AX, Y, B, X, Y, Z. We've got A, we've got B, we've got Y, Z, we've got X, Z, we've got X, Y, we've got X, Y, Z. Then we've got X going to X, Y, and X, Y. Then we've got Y going to B, BY, and Z going to A. So this is the new CFG formed as a result of removing null productions. Now killing unit productions. Kill unit productions. Right, so the unit productions, we have got S going to X, S going to Y, S going to Z, X going to X, X going to Y, and that's it. Right? So before we go there, one thing I forgot to mention earlier is that we've got what are called cyclic unit productions. Right, what they do is they take the format of, they've got transitive properties, right? So I've got S goes to X and X goes to Y. By default, if I have this, I will then go ahead and put S goes to Y. Right, because we're saying S goes to X, right? And then we deal with that. Then X goes to Y. So eventually S also goes to Y. So we're saying when S eventually goes to a non-terminal, so a non-terminal eventually goes to another non-terminal, then we say it is also a unit production. So do we have any of such nature? We've got S going to X and X going to Y, so S going to Y should be there. Fortunately, we have S goes to Y over there. Right? So we've got X going to X and X going to Y, X going to Y is there. So the new productions formed are going to be as follows. Number one, we've got S going to X. If S goes to X, which means S goes to X, XY. Right? Then if S goes to Y, then we're going to have S going to B and BY. So B is already there. What we don't have is BY. Right? So this is done. This is done. S goes to Z is going to go to A. It's already there. X going to X is already there. Right? No new production is formed there. X goes to Y. We're going to have X going to B, BY. Right. Now, the new CFG formed, new CFG, we're going to have S goes to AX, Y, B, X, Y, Z, A, B, Y, Z, X, Z, X, Y. Then X, Y, and Z are going to replace by, so X, Y was already there. There was no need for us to put this. Just put B, Y. So if you're unsure, it's fine. You can put it there. You figure out when you're writing down, you see that there's a duplication there. So you do not need the duplication. You can throw away 1 and remain 2. X goes to xy, bo, by. Then y goes to bo, by, and z goes to a. So this is the new CFG form. Right, next we have got Chomsky normal form. Chomsky normal form. Right. We do our 2 steps. First, we need to convert these to non-terminal going to non-terminals only. So we're going to have S goes to A, X, Y, B, X, Y, Z. A is fine, B is fine, Y, Z is fine, X, Z is fine, X, Y is fine, B, Y. X goes to X, Y, B, or B, Y. Y goes to B, O, B, Y. B, Y. Z goes to A goes to A, and B goes to B. Then after this, we put it in the Chomsky normal form. We need 2 non-terminals. We're going to have S going to AX is fine, Y, B is fine, X, Y, Z. So we're going to have X, let's call it R1 goes to Y, Z. Then we're going to have A is fine, B is fine, Y, Z is fine, X, Z is fine, X, Y is fine, B, Y is fine. Then X goes to X, Y, or B, O, B, Y. Y goes to B, O, B, Y. Z goes to A goes to A, and B goes to B. Like that. So that gives us our Chomsky normal form. So just go and try and reproduce this on your own for the assignment, and then if you can just go through the notes and see where you might be falling behind. Otherwise, you should be good to go. So you can even start attempting past exam paper questions. You find that this will have about 6 to 9 marks in the exam. Though there's a lot of writing, the level of difficulty associated with this question is not that much. So hence the mark allocation. Right, if there are no further questions, then I will call it a night. I know I haven't responded to you, Chanel. I'll do that tonight. But otherwise, I think we should be okay going forward. All right, thank you very much for attending. Enjoy the rest of your evening. Good night.